CleanAir responds to the problem of unhealthy indoor environments. With its temperature, humidity and CO2 sensors, it keeps tracking of internal air parameters. If environment conditions worsen, it warns the end user of the danger, and its control strategy provides the best solution to implement. The infrastructure is based on the microservices paradigm. It is made up of different isolated services, providing flexibility to the system and an easy-to-maintain platform. Every service runs as a Docker container, ensuring independence from low-level resources and cloud-like flexibility. The end user can add easily new devices, thanks to the high scalability. With Microsoft Azure Cloud Virtual Machine, the system is up and running in any moment. More specifically, the infrastructure is made up of 7 different services. The most important, on which all the system relies, is the catalog.
Catalog performs the dual function of service catalog and device catalog. It's the starting point for every service inside infrastructure. In fact, its purpose is to list all the services and devices endpoints, and the resources they expose in order to be able to communicate with them. Every service must perform regularly a ping operation to inform the catalog that is up and running. In fact, the catalog checks periodically if time from the last ping operation has expired, and if so, it removes the service from the list. Message Broker receives all the messages published under a certain topic, and it routes them to those who are subscribers to that precise topic. The infrastructure does not use an internal MQTT server, but it relies on external ones. For the reason mentioned before, different types of message broker can be selected in order to guarantee a solid infrastructure. The infrastructure has 2 different devices, a physical one composed by the Raspberry Pi and a simulated one. The Raspberry Pi contains several different sensors to measure temperature, humidity, CO2. Meanwhile, the simulated device, a fictitious device, contains a consistent data from an external ThinkSpeak channel, and it is used for completeness and testing purpose. Both the devices are configured via RESTful API and their data are published via MQTT. Telegram Manager exposes a RESTful API, which are going to be used by other services. In particular, the control strategy used it in order to notify the end user. Telegram is provided with a simple and fluent chat for the finite state machine model. It also performs some parameters configuration like the location to identify a certain device.
The external Weather API service contacts Open Weather API in order to get the current weather data, the air pollution data, the forecasted weather data and the forecasted air pollution data. These information are exposed via RESTful API to the other services and then processed by the control strategy. The Node-RED service provides a simple and user-friendly graphical interface in which the user can configure parameters in order to personalize the graphical visualization. The control strategy is the infrastructure core service and it receives and analyzes data coming from the devices. It does not simply check that the data coming from the various sensors are above the threshold limits, but it performs a multiple control in order to avoid spurious data problems. Furthermore, the control strategy alerts the user even if the device measurements have not reached a critical value yet, but are going to do so. This has been done by implementing a function which predicts the featured measurement value based on the past one, so that this service is able to understand if one of them is going to be critical in the next feature. Through the Telegram Manager REST API, the control strategy sends to the user the notification in case one of the value is critical. At this point, it analyzes whether the user has or not an external device linked to the platform, and, especially based on the actual external condition plus the air pollution level, the control strategy can suggest to the user what is the best action to do in order to restore an healthy environment.
ThinkSpeak is used in order to store, visualize and analyze live data streams in the cloud. it provides instant visualization of data posted by our devices. The ThinkSpeak adapter is our link between ThinkSpeak itself and the infrastructure. It is subscribed to Sensor Topic in order to be able to receive their live messages, and then it uploads them to ThinkSpeak via REST. It also performs daily, weekly and monthly statistics for all the measured quantities.
Now we are on the infrastructure.
If the external condition and the air quality outside are good, the user is told to open its window. Otherwise, the control strategy tells to the user to not open the window, but to open an internal door instead, or eventually to switch on the dehumidifier. Furthermore, based on the forecasted value provided by the external weather API, this service is able to inform the end user if and when the external weather and the air pollution level are going to return within normal ranges, so that the user will know in advance at what time to open the window.
Here we can see that the catalog is running and it provides the services list. We can see a real test case in which the user is notified via Telegram.